Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we will discuss about the basic structures and formats of writing an SQL query. We will start with the select clause, we will move to the from, where, rename clause, and then we will see that how to order, sort and use the aggregate functions and all other operations in a basic structure of SQL query. In SQL, we can say that we are performing a query and then executing the query to fetch a result from a relation or a table. That can be multiple relations or can be a single relation. So whenever we are writing a query, there is a predefined format on how to write that. The first and the basic foremost clause that is used in a SQL query is the select clause. The select command or clause is used to get the number of attributes or all the records in a relation. So the basic structure of a relation in a SQL query using the select clause look like: this is the basic structure where we need to write the word select and then we brief to attribute names we are specified in a relation. Then we need to put the word from and then we need to put all the relation on which or from which we want to fetch the attribute names. Now we will emphasize on the select keyword. The select keyword followed by the attribute names is the first concern in the section. So first we will use the select with a distinct keyword. Say for an example that a relation has an attribute city and there are cities which is repeated for a customer because customers can reside in the same city with other customers. But while we are naming the city that a company offers, we often use the keyword distinct. Now when we put the keyword distinct before the attribute name in a select statement, then we are making that we will count only the name once in each case. Say there is 3 cities, Kolkata, Delhi and Hyderabad in a company. So we will count Kolkata for once, Delhi for once and Hyderabad for once. So it will look like this. Now here we can see that we have put the distinct keyword before the attribute city and the relation name is company here. So the table is company, we are fetching the details of all the cities that is present there but only the unique one. Now we can do the reverse one by fetching all the cities that the repeated number of cities or all the values that is present in the relation in an attribute city. So we can use the statement like here. By using the keyword all, we are removing the constraint that we want the unique names of the values on the attributes. So this is a very basic format of using a select statement. Now that we have mentioned that we can put more than one attribute names in a relation, we can fetch all the attributes in a relation. So the very basic form to list the whole table or the values in a table is using see, this star stands for all the attribute names. That is, it will give all the details of a table name that is specified here. So it is the basic format of listing a table in SQL of a database. Now suppose we have a relation named loan, and the loan relation is consisting of the attributes So the loan attribute is called loan number, customer name and amount. So this relation has three attributes. Now we want to list all the attributes, but we want that the amount will be multiplied by 100. So we can use here in a select statement. This is the original table listing of loan. And now we want to display the corrected result, that is amount into 100, so we cannot use the star here. Even if all the attributes are present, but as we are making an adaptation, as in a general algebra of projection, so we have to use all the attribute names differently. See here the two uses of asterisks in SQL. When we are using the asterisk in a select statement, not using any multiplied value of a numeric one, then it will be used for all. Now, as we are presenting this asterisk here between a numeric value, another numeric value, or an variable value, then it is used for the multiplication or giving the product. So that is the two uses of asterisk in SQL. So that is all of the basic formats of selecting a statement. Now we will move to our next part, that is a where clause. So where clause is used to introduce predicates in SQL. Where using the select statement in relational algebra, we can use the predicates by the subscripting the value along with the sigma sign. Here we will write it out with command with a where clause. Now if, as we are using the previous example of the loan relation of loan number, account number and amount, now we are using a select statement to see all the details of a loan, whose account number and loan number, and the details of this loan relation with the customer name and the account number. Here inside this select clause, we will add a predicate that if the amount is greater than 30,000, then only we will list the loan number, customer number and amount. So we can directly write that the select star, because we need all the attribute information without any updation of the information. We are just sorting down the list so that we can take only the information of the amount is greater than 30,000. So we can done like select star from loan where amount is greater than equals to 30,000. But unfortunately, we cannot use this greater than equals to sign in an SQL query. We need to put two where clauses and combine it together with the AND clause. Now suppose we are using this where clause after the select star, so the SQL query will not work because it works only in this from first select, then from, and after that or last in where. So we need to again break it in two SQL queries and then merge it in a single one. So I will write down only the single one. So now that above 30,000, we are restricting it with the 40,000. So the greater than equals to clause or the operation is used here to mentioning that all amount will be around 30,000, but then we need to restrict with this AND clause that it is between 30,000 and 40,000. So now we can rewrite it using a between command that will replace by joining these two clauses or predicates. By this, we're using the AND clause. Now say suppose this is joining the predicates on a single attribute. We can even make two or more different attributes to become a predicate inside a select statement. So suppose we are using that the customers who are living in a city of Heisen and an amount greater than 30,000 and less than 40,000, I want the details of that customer or the customers. So now we have to write like this. See here we are actually joining two different clauses with the AND statement. So this AND keyword is just joining that amount is between 30,000 to 40,000 and city is equals to Hayes. Now other than using an AND, see suppose I'm saying that whose amount is greater than 30,000 and less than 40,000, or the customer can live in Hayes. So we can just change this statement, the AND, to an OR. So we can replace this AND with an OR so that we can get all the result if the customer is staying in Hayes or the customer has an amount greater than 30,000 but less than 40,000. So it will actually join all the operation, and this one will take an intersection or a common value that depends on both the Hayes and between 30,000 to 40,000 salary. The next type of statement we will use is a from. The from works with the select statement. From is mentioning that from where we need to take the attributes. It is actually defining the relation names from where we can actually choose the attribute names. So in our past examples, we are using this from keyword with always a table name or a relation name. Here we will see that we can choose multiple relation names using the from on a select statement. So we just need to write it select, say account number, account type and loan number from account, comma, loan. So here we are actually joining this to relation, just like in relational algebra, Cartesian product or natural join, and then fetching only the account number and account type from the account relation and loan number from the loan relation. So we can add any number of attributes of any number of relations inside a from clause, and it works just like the projection operation inside a natural join of this relational algebra. Next type of operator we will use is a rename operator. The rename operator aliases a name with another name. Say for an example, there lies the attribute names L, number, account type, SCTP, and balance, say BL and C. Now, when we are actually displaying this value to the customers or the end users, we are using the full names like the LOAN, number, NUMBER, or account type in full words. So we need to rename it just for the displaying. Say the select statement is basically used for displaying the or listing all above the attributes in a relation. So whenever we can rename it, we can put it in the select statement. And the fun part is that we can use the rename operator in the select statement as well as in the from statement. That means we can rename the attribute names in our listing of tables, as well as we can rename or give aliases to our table name or relation names. We will see one by one that how to do that. So the rename operator works like this, that the old name as keyword will actually rename it to the new name. So if you want to rename it with an attribute, then put the attribute name as the new attribute name. And if it is a table name, then also it works like that. So we will see that how to convert a normal query into a renamed query and what will be the result look like. See, our relation loan and account has the attributes account number, account type, balance, and customer name, loan number, amount. Now we are using a query which will fetch the customer name, loan number, amount, the loan dot balance from loan account relation. Now as we are matching, when only that the account balance will be same as the loan amount. So we are facing that account, that is a table name specified by dot by the attribute name, and then we are telling that loan dot amount, that is also a table name dot specified by the attribute name. So here we are using aliases now. So we will first try to rename the attributes and then we will put the table names as a renaming. Here we can see that we have given the loan dot balance as a new name, full word balance. So whenever the result will be there, we can see that instead of loan dot blnc, we will see the word balance full in here. Now we will go to the tuple variable. You know the work rename of as works best with the tuple variable. What is a tuple variable? We use the tuple variable, that is we are using for a record a particular variable which will be matched with other relations variable. And these two relations which we are using will be used as a tuple. So first we need to rename the table name and then use that aliases as a tuple to that relation or table. Now we will see that how to do that. See, here we are contradicting with the tuple. So the tuple here is a record that is being matched with this loan amount, balance, and account of the amount. So whenever this matches, then we are actually dealing with the records on that particular relation. So to define that records, we are renaming that the loan as T and the relation account as S. Now this T and S becomes a tuple variable. This tuple variable can be used even while renaming an attribute. See here, other than using the loan.blnc, we are using t.blnc, where we have already made it a tuple. Now we can also use the distinct keyword inside the select statement while renaming so that the tuple variable becomes unique in each case. Say for an example, again for city, we can use the distinct keyword and make the city as a tuple. Here we can see that the T.balance among matching with the amount on the account relation, we are actually having the loan and their residing city with distinct keyword. That is why we make the city as a tuple now, and we will calculate all the customer details according to the city names. That the Delhi, how many customers are residing, on Kolkata, how many customers are residing. So in this way we can make a tuple variable using the aliases of a table name. Next we will move to the most important part of our basic structure in SQL, that is a pattern matching or string operation. We know that we often want to find that the name of the customers in a company whose name starts with A, or even whose name starts with J. So there are a number of operations to actually deal with this string type of issues. We will discuss it one by one. As we know that star denotes for all, here in string operations we will use percentage sign to make any number of character matching. Say suppose we want to match that after starting the first character P, there can be any number of character. So we can write it like P percentile. So any name like Perry, Penny, Peter will be matched with this P percentile because it is starting, the first letter is P, and after that there can be any number of character. And if we want to denote a single character, that we can represent it with an underscore. Suppose I want to match the second character will be always E. So by using this P percentile, we can match any character that is starting with a character, and after that there can be any number of characters. So now we will look at examples that how to satisfy a pattern matching issues using the string operator percentile and underscore. First example is, say suppose we are saying that the surname can be anything but the name should be always John. So the pattern matching scheme will look like John percentile. That means after John there can be any number of characters and the characters can be anything. Now suppose we are saying that in the middle name or any type of the name there can be a character issue. So we should like percentile issue percentile. That means there can be any number before issue and any number of characters after issue. So the middle of the word or anywhere in the word the line issue is lying. Say suppose we want to check that a word consists of only 3 letters. So we need to put like underscore underscore underscore. That means only 3 letters will be matched and only 3 letters should be there in the word. Now if we want to check like there can be at least 3 letters. So we can make it underscore 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 followed by percentile. There can be a 0 letter after the 3 characters or can be more than 1 characters. It is guaranteed that there will be at least 3 characters in this word. Now, how to use it in a select statement? We will use it in a select statement that we are finding a pattern that the word en should be anywhere inside a word. How to match that? See, we are using the keyword like, that is actually equivalent to the sign equals to. So we are making that we are searching for a city where anywhere inside a word the 2 characters en lies. Anything before en and after en is allowed. So the like is being the city equals to this one. We can use that a starting name is A. So the employee name is A and we are fetching all the details and we can write it like select star from loan where CNAME like A percentile, so that all the names that starts with A will give us the information about the customer. Now, how to match a character if it itself consists of percentile sign? We need an escape sequence to actually denote the characters which are percentile and escape sign. So the escape sequence is a backslash that we need to put beyond any character. Just look at that. Here we can see that we have used an escape character before the percentile sign and itself the escape sign in the second case. So actually we are matching the pattern, that is AB percentile CD, anywhere inside the word, and in the second one in AB escape CD. So to get use of this percentile and escape character which has got a different meaning in this case, so we are using this escape sequence. Now the string operator provide much more information like to lowercase, uppercase, concatenation and all. Say suppose we are thinking that the customer care or the customer name starting with capital A or small a doesn't matter. That is not case sensitive. So how to do that? We can do that like select star from loan where CNAME like capital A percentile and CNAME like A percentile. So this we can combine using one single query. So we can see that now the customer name will be a case sensitive because the A percentile will be same as the small a percentile. So now we will move to the order by clause. So the order by clause, we are saying that will make the tuples or the table names order by a particular attribute. Say we want to order by the amount, or in a student relationship we want to order by a marks. That is the highest marks will be get in the first one and the lowest in the last one. So that is a descending order by. So by default the order by clause comes with ascending, and if we want to make it descending then we have to specify it. The ordering of the order by clause comes like select, from, where and then order by. So now when we are using the order by, if you are using any of these attributes first in a descending nature, then after that every attribute you want to put it in an ascending order by, we need to specify it explicitly. So now we will see an example that how to do that. See here, first we are using that the amount is greater than 30,000, so we are selecting the customer name that are unique, and now we have put two order by clauses. One is a customer name that is in an ascending order, that will be in alphabetically ascending order, and again an amount that is in a descending order of ordering. So now if we have reversed this letters, that amount descending comes first and customer name last, then we have to explicitly specify customer name space ASC to make it in an ascending order. Other than that, the customer name also will be ordered by in a descending way. Next we will discuss about duplicating a relation. Duplicating a relation becomes absolutely important when we are dealing with the relation in many of the cases. Say your personal contact details database is shared with your company, with your friends, in of any other groups you are attached with. So every time you need to make a duplicate of your group or the database of your personal contact details, so that you don't have to create it in every databases that you are attached with. So that is the basic facility of duplicating a table name or a relation. So now we will see that how to do that. We need to satisfy three clauses here. The first one is if there is C1 copies of tuple T1 in a relation R and it satisfies the selection theta, that is some predicates with a where clause in a selection, then there should be exactly C1 copies of tuple T1 in the selection of that particular list. Second one is each copy of T1 in R1, there exists the T1 that is belongs to the R1 relation of projection. And the third one is if there is two relation and two tuples and two number of copies C1 and C2, then exactly there will be C1 multiplied by C2 number of copies of tuple T1 multiplied by T2 in the relation R1 multiplied by R2. All here considered a Cartesian product. Now we will see an example to solve the third issue. Now here we can see that two sets R1 which has a combination of 1A and 2A as its contents and R2 has 2, 3 and 3. Now we are projecting the B values of the R1, that is A and A in both the cases, and now we are projecting of the R1 Cartesian product it with the R2 to make all the combination. So A2, A2, A3, A3 and A3, A3 will be there as my result. So we can see that there is 1, 2, 3, 4, 5. So 2 into 3 is 6 and there is exactly 6 number of copies in the tuples. So that satisfies the third issue. That is all for the basic structures of SQL queries. Thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.